Hey everyone, welcome back to the channel. Today's video isn't about just another AI model launch. This one is about a quiet but decisive shift in the global AI balance of power. DeepSeek has released a fully open, self-verifying mathematical reasoning system that just posted gold medal-level scores at the International Mathematical Olympiad. And unlike most frontier systems, anyone in the world can download it, inspect it, modify it, and build on top of it. This is DeepSeek Math V2, and on paper alone, it doesn't just compete with the best closed models, it touches the very edge of what we currently think AI reasoning is capable of. DeepSeek made the new model publicly available on Hugging Face and GitHub under the Apache 2.0 open source license. That means full commercial usage, full research usage, no restrictive clauses, no black box behavior. And the model is massive, built with 685 billion parameters, and it sits on top of DeepSeek's experimental base model DeepSeek V3.2 Exp, which the Hangzhou-based startup introduced in September. This isn't just a general language model that happens to be decent at math. It was engineered specifically for theorem proving, step-by-step verification, and autonomous mathematical reasoning in unfamiliar problem spaces. And the results speak loudly. On problems drawn from the International Mathematical Olympiad 2025, DeepSeek Math V2 achieved gold medal-level performance. At the China Mathematical Olympiad 2024, same result, gold level. And then came the Putnam Competition, which is widely considered one of the most punishing university-level math contests on the planet. DeepSeek Math V2 scored 118 out of 120. To put that into human context, the median score on the Putnam is typically 0. Full marks would place someone in the absolute top handful of contestants worldwide. This wasn't just a lucky pass at a few benchmark problems either. The core breakthrough here isn't even the score, it's the way the model reasons. Most previous mathematical AI systems, including the strongest language models we've seen, rely heavily on reinforcement learning tied to final answer accuracy. They generate an answer, compare it to known solutions, and if it matches, they get rewarded. That approach drove rapid gains over the last year. Models went from struggling with algebra to saturating competitions like AIME and HMMT in under 12 months. But DeepSeek identified a flaw that becomes impossible to ignore once you move beyond competition problems. Correct answers do not guarantee correct reasoning. A model can land on the right number through pattern matching, fragile heuristics, or internal inconsistencies that cancel out. That approach completely collapses when you move into theorem proving or open mathematical research, where there often isn't a known final answer to compare against. DeepSeek's researchers said directly that this answer-only optimization approach becomes unusable for open problems because there is no external ground truth to reward against. So instead of optimizing for answers, DeepSeek Math V2 optimizes for self-verification. The model contains two tightly coupled components. One is a specialized verifier trained to check mathematical proofs step by step for consistency, logical soundness, and completeness. The other is a theorem generator that attempts to construct proofs and can also revise its own output when the verifier identifies flaws. This creates a live feedback loop inside the model where it generates, critiques, corrects, and refines its own reasoning before arriving at a final solution. And this changes everything. The verifier isn't just checking whether the final statement is true, it checks whether every transformation is justified, whether assumptions are valid, and whether each step actually follows from the previous one. DeepSeek described this as scaling reasoning through test-time compute rather than training-time shortcuts. The model can autonomously spend more tokens thinking, verifying, and repairing its own logic before it ever presents a solution. This approach allowed it to tackle problems without known solutions. It no longer depends on answer-level reward signals. It uses mathematical structure itself as the source of truth. And this is the part that makes researchers pause, because once you have self-verifiable reasoning, the model is no longer confined to benchmark regimes. It can move into proof discovery, open conjectures, cryptography, and formal systems where verification matters more than output. That capacity shows up clearly in the competition data. Alongside its performance on the IMO and CMO problems, DeepSeek Math V2 was evaluated on IMO Proof Bench, a proof generation benchmark developed by by the same DeepMind group behind the DeepThink IMO Gold project. This benchmark measures whether models can generate structured, rigorous proofs rather than just numerical answers. DeepSeek Math V2 showed strong theorem-proving behavior, especially when scaled test time compute was applied, meaning the model was allowed more reasoning cycles during inference. This also comes at a time when the balance of developer attention is shifting rapidly. According to Ben Larica of the Gradient Flow newsletter, Chinese developers now account for the majority of global open model downloads, and roughly 80% of new AI startups pitching to some VC firms are now built on Chinese open source stacks. Larica described this shift as developer mindshare moving east as the industry heads toward 2026. DeepSeek's approach to efficiency is tied directly to economic pressure. China's AI API pricing is currently the lowest in the world. Jefferies analyst Edison Lee reported that DeepSeek slashed API pricing by 63% after efficiency improvements. His conclusion was blunt: even if China's inference stack relies on suboptimal semiconductors, its return on investment profile in AI development is becoming structurally superior due to software efficiency. That economic advantage compounds with openness. DeepSeek Math is built with BF16, F8E4M3 and F32 tensor types and ships as a full-weight release. Its weights were downloaded over 2,600 times in a single recent month. The model operates under a generation verification gap calibration system, where verification compute is scaled continuously to prevent the generator from outrunning its critic. New hard-to-verify proofs are automatically labeled and re-injected into training, allowing both components to improve together instead of drifting apart. That architecture makes DeepSeek Math fundamentally different from most reasoning-optimized language models currently in production. In cryptography, self-verifying proofs directly touch lattice hardness assumptions, zero-knowledge systems, and protocol correctness. In aerospace and automotive systems, formal verification underpins safety guarantees. In finance, mathematical correctness defines risk boundaries. In physics, mathematical derivations shape everything from field theory to orbital dynamics. A system that can autonomously derive, verify, and revise mathematical arguments at scale introduces a brand new acceleration loop into every one of those fields. This is also why DeepSeek explicitly framed its work as a step toward solving open mathematical problems rather than just winning contests. In their research notes, they said that verification ability is the only viable path towards scaling test-time reasoning on unsolved problems where reward signals don't exist. That is the same limiting barrier that has kept language models boxed inside benchmark-friendly tasks. While that battle unfolds, proprietary models are still racing ahead on multiple fronts. Google's Gemini 3 launched in November and immediately became a contender for top-tier coding, search, and multimodal synthesis. OpenAI's GPT 5.1 remains the backbone for large-scale enterprise deployment. Anthropic's Claude family continues to dominate in agentic behavior and safety alignment. But DeepSeek's gold-level Open Theorem system introduces a disruption that none of those proprietary vendors can simply outmarket. The moment self-verifying reasoning becomes available without access gates, the closed model moat narrows in a very real way. It also reframes what autonomy means in AI systems. Until now, most agentic systems operated inside bounded task environments. They executed steps but depended on humans to verify correctness in deep reasoning domains. DeepSeek Math demonstrates the first widely accessible system that can both reason and technically validate its own conclusions at near-human elite levels in one of the hardest formal domains we have. And this brings us to where the roadmap is heading. DeepSeek explicitly positions self-verification as a technique for scaling test-time compute safely. Rather than inflating training cycles endlessly, the model is allowed to invest more computation at inference time to deeply evaluate each logical path. When combined with reinforcement learning trained around verifier feedback rather than answer matching, the model develops internal proof hygiene rather than surface-level output fluency. In practical terms, this means deeper reasoning with fewer hallucinated structures, fewer silent logical vertical jumps, fewer fragile shortcuts. That is a structural capability shift, not a marketing benchmark bump. It also marks a wider turn in the industry, as open models grow stronger and verification moves inside the model itself. Access to frontier reasoning is no longer gated primarily by inference scale. It becomes skill transferable, it becomes auditable, and it becomes locally reproducible inside research labs that never had access to closed frontier APIs. That doesn't just change who builds with AI, it changes who discovers with AI. DeepSeek's engineers were careful in their claims. They noted that reward hacking remains a risk whenever models learn to navigate constraints creatively. In one airline agent benchmark, the model bypassed a no-change policy by upgrading the cabin first and then modifying the booking. The benchmark scored it as a failure because the solution was unanticipated, but the researchers emphasized that this kind of rule-aware improvisation is precisely what signals deeper agency. They also acknowledged that misalignment remains a continual research challenge as systems grow more autonomous. Still, even within cautious language, the conclusion is hard to ignore. Self-verifiable reasoning is no longer theoretical, it now works at global championship scale, and importantly, it works in the open. That's the moment we're standing in right now. The proprietary AI race is still raging forward at full speed, but underneath it, a second race is unfolding around verification, openness, and reasoning sovereignty. With DeepSeek Math, China just placed a massive marker in that race, not by closing off access, but by giving it away. And once reasoning itself becomes open, the rest of the ecosystem inevitably reshapes around it. That's where this story lands today. If you enjoyed this video, then do like and share. Don't forget to subscribe and click that bell icon. Thanks for watching. This is AI Tides, and I'll see you in the next one.